up to 1, 2, 3. Brand new idea for you first-time pre-calcers. Now, if you're watching this in 2023, 2024, you learned this stuff in Algebra 2 already, so this should be like a reminder. So here we go. These are called piecewise functions. That's a fancy name for, we're going to take a piece of that function, graph, and a piece of this one and see what they look like together. So really, it's not that big of a deal as long as you know your basics in graphing. So here we go. We're going to start with this. But notice they're saying, hey, there's some limitations. X is less than or equal to 1. So if we went 1, 0, -1, -2 maybe, and plug some of those in, 1 squared is 1, minus 2 is -1. 0 squared is 0, minus 2 is -2. -1 squared is 1, minus 2 is -1. -2 squared is 4. 4 minus 2 is 2. And I'm going to go ahead and go down to -3 so you can see it. -3 squared is 9. 9 minus 2 is 7. If I start plotting these points, 1, -1, 0, -2, -1, -1, and -2, 2, and then -3, 7 would be 4, 5, 6, 7, somewhere here. You can see that we would go here forever. Remember, this could be -4, -5, and it just keeps going up, 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 up. There's an arrow. It goes down like this, and then it stops. And this is the piece of the parabola that this wanted. All right. So someone else out there could have said, well, Mr. Kleefish, y equals x squared is a parent function, and it looks like this. And then all you got to do is drop it down 2, because that's what this does. And I get that, but I like to use this to really get firm limits on what's going on. So with that being said, I like using these. And now this one is 1/2 x minus 3. Now all that is y equals mx plus b for y equals 1/2 x minus 3. So I know that that line looks like 1, 2, 3. There's the y-intercept. I go up 1 and over 2, and then the whole line would look something like this. Now notice what they want. X is only greater than 1. So if I took 1 and I plugged it in here, I'd get 1/2 times 1 minus 3. That's 1/2 minus 3, which is essentially -2.5. So if I went 1, -2.5, it'd be right here where they want this graph to start. But watch this. Open circle, and none of this else matters. So it starts here and goes that way forever. And this is the piecewise function. So now that I've graphed it, remember, x is greater than means open circle. Less than or equal to means filled in circle right there. So here's my piecewise function, and then they're going to ask you, what's the domain? Well, that's asking you how far left does it go? Well, if this thing kept going wider and wider, or up and up and up, it keep going wider and wider and wider, so it would go to -infinity. And then how far to the right would it go? Well, because it goes here, and then it picks up here again and continues to go in the right direction, really what I would say is x is greater than -infinity, less than +infinity. Now what about the range? The range is my y value. How low does it go and how high does it go? Always start with how low it goes. So how low does this graph get? Well, it gets to right here, which we said -2.5, but it's an open circle. So that would be y is greater than -2.5. But then as you can see, this goes up and up and up forever, up and up and up forever. So it's less than infinity. Now is this continuous or not? Well, you can see there's a break here. So we say, nope, that is not continuous. All right. I'm going to show you one more similar to that, and hopefully you'll wrap your brain around it. Okay, different example. This is called an exponential function. We've dealt with those. So we got 3 to the x power. So as you can see, x is less than or equal to 2. That means it's going to be a filled-in dot. You might want to make yourself a note there. X is greater than 2. That's going to be an open circle. You could give yourself a little clue right away so you don't screw that up. Well, let's talk about this top one. This is y equals 3 to the x power. Now, x is less than or equal to 2. I'm going to go 2, and then 1, and then 0, and then maybe -1, and just see where this goes. So, 3 squared is 9. 3 to the first power is 3. 3 to the 0 power is 1. 3 to the -1 power is just 1/3. I'm going to stop right there and see what that does. 1, 2, or 2, 9, I mean. 3, 4, 5, 6, 7, 8, 9, somewhere up here. 1, 3 would be right here. 0, 1 is right here. And then -1, 1/3 would be right here. And maybe you remember what these kind of look like. Whoops, I'm supposed to stop right there. See how easy that is? So I stop there because x is less than or equal to 2. So I don't keep going because that would mean x is greater than 2. And then it goes on forever because all these x's are less than 2. So there's that one. So this other piece, x is greater than 2. So I'm going to go like this. And all I need is really 2 spots. So I'm going to pick 2 and 3. See how that works. So 2 times -3 is -6 plus 6 is 0. 3 times -3 is -9 plus 6 is -3. So 2, 0, open circle, and then 3, -3. 1, 2, 3, and then down here. And that goes, that's a line, so that would go like this forever. All right, so let's do this backwards. Is this continuous? No, there's a big break in them. I should have shown you a continuous one. A continuous one would look something like this, where something goes like this, and then stops, and maybe that goes forever, and then it goes like this. This would be yes, it's continuous. So you can see this is a no. Let's talk about the domain. How far left does it go? Well, that thing never stops. So x is greater than -infinity, less than. Now how far to the right does it go? Well, I know this thing stops here, but this thing keeps going down, 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 but we're talking how wide does it go as it goes down, down, down. And because that arrow never stops, that's also going to be infinity. Now range, how low does it go? You can see this goes down forever. So y is greater than -infinity. But then it goes up, 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 and it stops right here, right at 9. So it's less than or equal to 9. Pay attention to those less than or equals. We talked about it being not continuous because there's a break right in here. All right, hopefully that kind of makes sense. Okay, back to this. This is a general equation with rules associated to A, B, C, and D. And I like the way this author is kind of like chunking it up into little pieces. So let's review C. If it's plus C, that's left C. If it's minus C, that would be right C. D is pretty simple. If it's a plus D, it's up D. If it's a minus D, it's down whatever D is. Now we're going to talk about the letter A. The letter A's got some interesting things about it, but let's talk about it and make sense of it. So if I actually took y equals x squared and I took a few little x's, plugged them in, I get 9, 4, 1, 0, 1, 4, 9. And again, we have said that it looks like this. Now, I'm not going to be too perfectionistic about this, but if I doubled all of my x squareds to figure out what my y's are, then for this one, my x's would be the same, -3, -2, -1, 0, 1, 2, 3. But I would double these, 18, 8, 1, 0, 2, 0, 2, 8, 18. Well, if I plotted all of these, it would go like this. It'd be going up faster. So this, A, is called a vertical stretch because it's going up faster, which you could say it's skinnier, narrower. But look at it. What if this is 1/2? Well, then I would take a half of all of these. I'll get a different colored marker here, green, and essentially I would take a half of all of these. So that would turn into x, y, -3, -2, -1, 0, 1, 2, 3, 4.5, 2.5, 0.5, 2, 4.5. Essentially, if I plotted these, again, this is my parent function, which was purple, and now my y's are not going up as fast, so it's going to be like this. This is called a vertical shrink, which some books will call it compression. Okay? So get used to that. If it goes up faster, it's a vertical stretch. That's when A, if A is greater than 1, it's a stretch. If A is a fraction, in other words, less than 1, that's going to be a shrink or a compression. Okay, here's one of our parent functions we learned very early, y equals x cubed. Just to prove it, I got my x's, and then I cubed them all to get my y's. If I plotted all these, it would look something like this. And you guys have seen that before. So what is that? That's my A. Now, a lot of people want to say that's my B because it's connected to my x. But no, you're only going to have a B if there's parentheses or if there's absolute values and you have something like x, whatever, +1 or -1. The A is out in front always, so that's my A. Well, it's a whole number. I'm going to do this one in purple. So that means it's a vertical stretch, which means it's narrower. I'm going to go with a green one here. Now again, remember, we're comparing this to the original purple one. No, the original red one. And so it's wider than the red one, so it's not going up as fast. So it looks something like this. Now, if this was a 2, it'd be the same. If it was a 4, it'd be the same. We're just getting the general idea that a fraction makes it vertically compressed. It just doesn't go up as fast. All right, real quick review of geometry and circles. 360 degrees in a circle. And they're going to ask you for the length of arc BC, which means it's half of the circle's circumference. Well, if the formula is 2 pi r, and that's 2 times pi times r, which is 6 inches, which would be 12 pi inches. Now, pi is 3.14, so we're talking around 36 or so inches. Now, what about length of arc AB? That's from here to here. That is 45 degrees, so we're going to have to go 45 over 360 times 2 pi r. It's the fractional part. So that would be 1/8 times my whole circumference, 12 pi, and then I would reduce it. 4 goes into that 3 times, 4 goes into that twice, so it's 3 pi all over 2 inches. A little review for you. Okay, limited time to explain this, so here we go. If I got f of x equals 1/2 x plus 1, written in red, y-intercept is 1, up 1, right 2, draw the line in. If I take and I find the inverse by switching x's and y's and solving for y, and then graph this, it would be the purple graph. Now, one thing you need to know, and the author decided to wait till now to share this with you, is all inverses will be a perfect reflection over the y equals x line. And you can see that that's true. That's something you just have to know. And that's something you put in your toolbox.